Hi, you already know about irrational numbers, isn't it? All those numbers which cannot be expressed in the form of p by q, where p and q are integers and q is not equal to 0. For example, root 2, root 3, pi, all these numbers are irrational numbers. Now here, we'll prove that root 2 is irrational. How will we do that? We'll use the method of contradiction. What do I mean by that? I'll assume root 2 to be a rational number first and then prove that our assumption is incorrect. Hence, let's assume root 2 as a rational number. Therefore, we can write root 2 as a by b. Now here a and b may have few common factors between them. Let's cancel them out. Then we can write root 2 as c by d. Here c and d do not share any common factors. Or we can say that c and d are co-prime numbers. Now if I modify this equation, I can write it like this. If I square it, I'll get the equation like this. Here you can very clearly see that c squared is a multiple of 2. That means 2 divides c squared. Now you have done one theorem that says if p divides a square, then p also divides a, where p is a prime number and a is a positive integer. Hence, here we can say as 2 divides c square, therefore 2 also divides c. Or we can assume c to be some 2 times p. Let's replace this value in the equation. Here, if I square it, this is what we're going to get. If I cancel out the common factors, this is how the equation would look like. Now here you can again observe that 2 divides d squared. Hence, by applying the same theorem, we can say that 2 divides d. Therefore, we can conclude that 2 divides c as well as 2 divides d. Therefore, c and d share a common factor which is 2, which further implies that c and d aren't co-prime numbers because it has one more common factor apart from 1, which is 2 in this case. Therefore, we can finally conclude that root 2 is not a rational number. Our assumption is incorrect. Hence, the final statement will be that root 2 is an irrational number. In fact, you can use the same process to prove square root of any prime number to be irrational. Thank you.